Hello students. So in this session we are here to discuss one of the most important chapters in mathematics, which happens to be circle and tangent to a circle. So before I proceed, make sure that you do like, share and subscribe and press the bell icon to get notifications of further uploads. Now observe these three figures. So here in the first figure I have a circle and I have a line, and the circle and the line do not touch each other. And in the second figure here, we observe that the line, the straight line, intersects the circle at 2 points. So this is one point and this is the other point. So let us call this as P and Q. And here I have the third figure where the line touches the circle at only one point, A. So here we find that the circle and the line just touch each other at only one point, and this line happens to be the tangent to the circle. And this point A is referred to as the point of contact. Right? So therefore, the tangent touches the circle at the common point at only one point, right? And this line is referred to as the tangent to a circle. So there are some very interesting properties of the tangent and the circle. So now let's talk about one of the most important theorems. So here the tangent at any point of a given circle is perpendicular to the radius through the point of contact. So this is the first theorem. So let us consider a circle, and then I have a tangent to the circle. So let this point be called as point P, and then this line is line XY, and we have the center of the circle O. Right? Now this is the tangent because it touches the circle at only one point, and the point of contact is point P. Now let me join the center of the circle O to point P. Now we know that a line from the center of the circle to the circumference of the circle is known as the radius R. Now we need to prove that this line OP is perpendicular to the line XY. Right? So the tangent at any point of a circle is perpendicular to the radius through the point of contact. So if I consider another tangent here at some other point, and if I join the center of the circle to that point of contact, we need to prove that that line and the tangent would also be perpendicular. So these two lines, that is the line OP and XY, are perpendicular. So we need to prove that. So to prove that, let us consider another point Q, which lies outside the point P. So we consider another point Q. So Q lies outside the circle. So let us consider a point Q on the line XY, and Q lies outside the circle. Right? So now we find that if I join OQ, definitely OQ would be greater than OP. Now if I consider any point on the line XY other than P, so whether I consider a point here, here or anywhere on this line XY which is outside the circle, we find that all those points when joined with the center of the circle will always be greater than the line OP. So this happens at every point except at the point P. So therefore we conclude that OP is perpendicular to the line XY. So we realize that if I consider tangent here, say if this point is point S and I join OS, so definitely OS would be perpendicular to the line AB. So this is true for all the cases. So you consider any point on the circle. So any point on the circle having a tangent would always be perpendicular to the radius through that point of contact. Right? So with these fundamentals, let us solve all the problems given in the first exercise. So the first exercise, first question, how many tangents can a circle have? So let us consider a circle. How many points are there on the circle? There are infinite number of points. And at each point, I can have a line which touches that point on the given circle, and that becomes a tangent at that given point. So since there are infinite number of points on a circle, so definitely we can have infinite number of tangents. So how many tangents can a circle have? Infinite is the answer. Now, the next question 2, we need to fill in the blank. The tangent to a circle intersects at only one point, right? So given a tangent, it intersects the circle at only one point, and that point is called as the point of contact. The second one, the line intersecting a circle at 2 points. So suppose there is a line, it intersects the circle at 2 points, and that is called as a secant. So the next one, a circle can have dash parallel tangents. So we have a circle here, and this is the center of the circle, and I have the radius. Let this be point P, and let me have the tangent at point P. Now if I extend the radius to touch the other side of the circle, it is Q. So PQ becomes the diameter, and we find that P and Q are exactly opposite of each other. And if I have another tangent touching the point Q, so then we realize that these two tangents would be parallel to each other. So a circle can at most have two parallel tangents. So these two tangents would be parallel. If I consider two other points on either sides of the diameter of the circle, and if I consider two more tangents, now these two tangents would be parallel. So a circle can have a maximum of two tangents which are parallel at most. Next, fourth one, the common point of a tangent to a circle and the circle is called as the point of contact. So this is called as point of contact. Right? So this point is referred to as the point of contact. So question 3, a tangent PQ at point Q. So we have a circle here, right? And then there is a tangent PQ which touches the circle at point P. That is given. So a tangent PQ at point P of a circle of radius 5 centimeters. So let O be the center of the circle, and if I join OP, so the radius is 5 centimeters, and we know that the radius and the tangent are perpendicular to each other, so the angle is 90 degrees, meets a line through the center O at a point Q, so that OQ is 12 centimeters, right? So this tangent PQ, so this point Q meets the center of the circle O, and this distance OQ happens to be 12 centimeters. Right? So now we need to find the length of PQ. So what is this length? Now this triangle OPQ is a right angle triangle with the hypotenuse being 12. So therefore what is PQ? PQ by using Pythagoras theorem is nothing but OQ square minus PO square. So that is 12 square minus 5 square. So we know that 12 square is 144 minus 25, which is root 119. So the right answer is D, which is 119. The fourth one, draw a circle with two parallel lines. a tangent and a secant. So I need to draw two lines which are parallel to each other, where one happens to be a tangent and the other happens to be a secant. So let me consider a point P and let me draw a tangent at point P. So this point P happens to be the point of contact. Let me draw a line which is parallel to this tangent. So a line which is parallel to this, passing through the circle, intersecting at 2 points A and B. So this forms a secant. So we have a tangent and we have a secant line. So this is a fairly simple exercise, the first exercise given in circles, where we have learned what a tangent is, right? And the tangent and the radius at the point of contact are right angled to each other, perpendicular to each other, we should say. So with these properties, we have just solved these simple problems, right? So the next session, we will go through all the theorems associated with the tangent to a circle and also solve the next exercise, which happens to be very interesting. So make sure that you do like, share and subscribe and press the bell icon to get further notifications on the uploads, and thanks for watching.